All right, so right now we are on Journal 69, and this is part 2 of Journal 69. And we're going to start out with Bellwork. And Bellwork, you have to have 3 lists here, and you're going to have to find the mean, median, and mode. So take a look at these 3 lists first. I would start out by finding the mean. So if I'm trying to find the mean for part A, I'm going to have to sum up all the numbers and then divide by how many terms there are. So on the first list here, there are 6 terms. And so if I want to find how many or how much is the mean, I'm going to add all up my numbers and then divide by 6. And I get the mean to be 68.3. Careful. Sorry about that. So then the median is the middle number. So if you look at this list here, the 2 middle numbers are 78 and 80. So if you take the average of that, you're going to get that middle number. So anytime you have 2 numbers in the middle, just take the average. And I get the number to be 79. The mode here, if you look at this list, there are no repeats. So all the numbers only show up once. So since there are no numbers more frequent than the other, there is no mode here. All right, so if we take a look at the second list here, part B, notice how it's the same, but there is one term missing. It's the 0 one. Well, for this one here, I want you guys to find the mean because I want to see if we were to drop the 0, how does it affect the mean? So notice how the number of terms have dropped down to 5. And so if you sum up the numbers, you're going to get the same number, but you're dividing by 5 now. It's a smaller number. So if you divide by a smaller number, you're going to get a larger mean. So when I calculate the mean here, it's going to give me 82. The median here, well, is our middle number, and our middle number here looks like is 80. So I'm going to grab that 80 here. And mode, this list is pretty much the same as before. So mode, there's no repeats here, so no mode. All right, so let's take a look at part B and part A. So this 0 here, let's think about how a 0 would outcome when you're taking a test, right? So that student that made a 0 probably just was having a bad day. Either he didn't show up to class, or she was just feeling sick and turned in a blank sheet of paper. Who knows? But all that means is that test score there was just a fluke, right? And it's going to, even though that wasn't a good test score, it's going to affect the mean a lot. So what we call this test score here is like an outlier. It's basically a data point that is not going to be true to the other data points because it got messed up in some sort of whatever the condition was. So this is what we call an outlier. And so outliers have a major effect on the mean or the average. Whereas, notice how the median here is not affected by much. This one was a 79, this one's an 80. Mode here didn't really apply to this question. And part C here, we're going to do the same thing. We're going to find the mean, median, and mode. So the mean here, if I were to calculate that, I get 81.43. I just added the numbers and then divided by the number of terms. This time the number of terms here is 7. If I look at the middle number here, our middle number here is also 80. But notice that this time around, 80 shows up 3 times in our list. So we do have a mode here. Our mode here is 80. And in this time around, 80 shows up quite the majority of the time. So in this case, I can probably say that 80 represents really well on my test scores in this sample size. Now, what I want you guys to do is figure out which one, mean, median, or mode, represents the list the best. Notice how part A, the outlier, messed up the mean. So because there's an outlier here, the mean might not be your best choice to represent this data. So a better choice here is probably the median. Whereas part B, the mean here is, we threw out the outlier, so it's not affecting the mean anymore, so the mean's probably a fine one to use here to represent the data. Now, mean is something that we would typically use to represent the data. It's usually the best one to use. However, unless you have an outlier. So watch out for that. Now, if you have a number that's occurring a lot more often than the other numbers, then not only do you have a mode, but mode might be the best one to represent your data. All right, so let's sum this up and summarize how you can figure out which best represents your data, mean, median, or mode. So the mean is best when there aren't any outliers, like example part B. And median is best when there are outliers, so that's like example part A, where we had that outlier. And then last but not least, mode is the best when it's a number appearing a lot more frequent. So that's like part C. Okay, so now let's move on to another topic here. We're going to go back to using standard deviation in our next topic. So let's talk about normal distribution. So for this type of curve here, we call it a normal distribution because it has this generic shape where the peak here is what we call the mean. So the mean will always be at the peak. And because this has like a bell-shaped curve, sometimes it's known for just being a bell curve. So the first thing we're going to do here is place the mean in the middle. So the middle part here is our mean. And then if you want to calculate the rest of the curve, you have to know what the standard deviation is. So once you calculate what the standard deviation is, if you don't know how to calculate standard deviation, make sure you watch Journal 69, Part 1. So with one standard deviation, if you go to the right, you are adding that number to the mean. If you go to the left, you would have to subtract by one standard deviation. Now, what does that mean referring to, like in a real life example? Well, let's say that your mean for your test score, so in my class, the mean or the average was 70%. And the standard deviation, so standard deviation as in that sigma symbol, is what we call the standard deviation. Let's say that the standard deviation for this test was 10. So if the mean 70 and the standard deviation is 10, you would have to add 10. So that tells me within one standard deviation to the right, it's 80. And if I were to go to the left, I would have to subtract 10 from the mean, which gives me 60. So 70 minus 10 gives you 60. So that means within one standard deviation, I can say that that test score is between 60 and 80. But what that really is saying that is in one standard deviation, 68% of my students will score between a 60 and a 80. So standard deviation helps us find the range for that given percentage. So these percentage here will always be the numbers that you're using, but the range will change depending on what your standard deviation is. So for one standard deviation, it's always 68%. If you were to go out to standard deviation, right and left, you would cover about, or at least 95% for two standard deviation. So using that example again, if the standard deviation was 10, two standard deviation would be adding 20 to the mean if you were going right. So now this number would be 7 plus 20, which is 90. Whereas you would go to the left, you would be subtracting 20 from the mean, 70. So that would give you 50. So we would be ranging from 50 to 90 would be 95% of my students would fall within that range. So students would be scoring from a 50 to a 90, somewhere in between those test scores. Then lastly, for 3 standard deviation, you would multiply your standard deviation by 3. and that would cover at least 99% of the of your test scores or whatever you're trying to calculate. All right, so let's do an example of how you would do this in the real world. Okay, so now we're going to try to measure the heights of 10 people, and these data here are actually from I believe first hour's height that I've collected. So we're going to use their height to do this example. So I'm going to write down their heights here. 66 inches. Oh, by the way, these are in inches, not feet. 75, 65, 70, 72, 69. Sorry for the background. I am recording this video at the state tournament. So keep that in mind. If you need to make the volume a little higher so you can hear my voice, feel free to do that. I'm going to calculate the mean here. So using my calculator, add up all the numbers, divide it by the number of terms, which is 10. And that gives you about 66.6. Let's round it to 2 decimal places. So if you are writing a description for this, I would recommend to probably round to the nearest whole number, just so it's easier to write when you are writing your final conclusion. So I'm actually going to round this mean to 67 inches. And then I'm going to calculate the standard deviation. I'm not going to work out calculating the standard deviation. I'm actually going to just use a program here to calculate that, but make sure that when you do your project, you do calculate that by hand. So that standard deviation for all these given points is 3.88. So I'm going to round that to 4, the nearest whole number. Now, just so you guys remember, a standard deviation is the average distance between each point to the mean. So this is how tells us how spread apart the numbers are. This number is pretty low, so it's good number. So now what we're going to do is draw a normal distribution curve or bell curve, so that we can find within that percentile what is the range where these values are going to fall. I'm going to draw myself a bell curve. There we go. So remember, the peak of this curve here is always going to be our mean. And our mean here is 67 inches. All right, so now from here, let's take a look at one standard deviation. So for one standard deviation, it is about 4 inches. So if you go out to the right, one standard deviation, you're going to be adding 4 to the mean. So 67 plus 4, that's going to give me 71. Now, if I were to go the other direction, I would have to subtract by 1 deviation. So that means that 67 minus 4, 63. So that tells me that 68% of the values are within 63 inches to 71 inches. So in that data, at least 68% of the data will be within this range. Now, if I want to cover more ground, so 95% of the data, I need to calculate 2 standard deviations. So let me just remind ourselves, this was for 1 standard deviation, this is going to be for 2, and the last one here will be for 3. So for 2 standard deviation, 2 times 4 gives us 8. So you would be adding 8 to 67, which is 75. Or what you could do is just take 4, the standard deviation, and just add it to the 71 to bump up the number. And the same thing here, if you want to figure out what the next standard deviation is, you would just subtract 63 from 4. So if I take 63 and subtract 4, I get 59. And so that tells me it's from 59 inches to 75 inches. And if I want to calculate 3 standard deviations, that is going to be, let's see, 75 plus 4 gives us 79. And then if I take 59 and subtract it by 4, I get 55. So 55 inches to 79 inches. All right. So there we have it. Within 99% of our data is between 55 inches to 79 inches. Okay, so on here, this is going to help you guys figure out how to write your description for your standard deviation. So once you calculate that standard deviation for your project, you need to let me know how to you need to describe or write an interpretation of your standard deviation. And one way you could do this is to figure out what your 68% values ranging from. So you can calculate that by using that normal distribution curve and tell me all those values there. So you can just state what your 68% of your values are ranging from, or you could do it for your 95 if that's a better range, or your 99, or you could do all three of them, and that'd be great too, but you don't have to. I do need to see at least one of them though. All right, so I hope that helps you out with your project. So let me know if you have any questions in class.